Welcome to Semantic Backup Exec 2012 Data Management. If you're following along in the book, we're in Lesson 4. In this lesson, we'll discuss data lifecycle management, which describes how data is kept on on-disk storage devices. And then we'll talk about managing media for removable media. This is tape and removable disk cartridge, and using media sets. So we'll talk about the properties of media sets and how they're created. The last topic is catalogs and how Backup Exec keeps track of where your data is when you back it up, and the importance of catalogs. Let's begin with data lifecycle management. Data lifecycle management pertains only to on-disk storage, whether it is disk-based storage or data deduplication storage. It is a time-based retention management. In the backup job, you say how long you want the data to be kept. And then Backup Exec will proactively delete data when that time has expired, or if storage is needed, if additional storage is needed. We will always maintain the last recovery point or the last backup, and we'll talk about the dependencies for those backups. So this prevents data from being deleted out of sequence. You can also tell Backup Exec to retain the data if you need to keep it for a longer period of time. So data lifecycle management is a time-based retention. You tell it how long you wish for that backup to be kept. Whether it's fixed disk or cloud storage, it only pertains to disk-based storage. And that is set in the job. You say how long you want the backup to be kept. By default, every 4 hours the server will evaluate that disk storage and see if anything is eligible, any drive space is eligible to be reclaimed. If you should hit a low storage threshold, there are 3 of those. They were discussed in the configuration lesson, in the installation lesson. There are 3 low disk space thresholds. If one of those should be hit, data lifecycle management will kick in and see if any data is eligible to be deleted so that we can reclaim disk space. It is proactively groomed. Data is deleted if the backup set has expired, if nothing is on hold, and there are no dependencies. In other words, I can't delete a full backup if there are differentials or incrementals that are dependent upon that full. And we'll talk about dependencies more in a moment. The last backup will always be kept. The most current backup set, meaning full and the partials that go with it, will always be kept regardless of their time period. Dependencies have to do with you have backups that must be restored in a specific order. A full backup is self-contained. It's dependent upon itself. Partial backups, incrementals and differentials, must be restored after a full is restored. So you have to keep the entire set. I have to keep the incrementals in the right order plus the most recent full that goes with them. In case I had to do a restore, I would need to restore all of that. Differentials are only dependent upon the last full. So I don't have to keep a full set of differentials, only the most recent one, and it's full on which is dependent. So sets may be deleted if it's not the last copy, and if there's a duplicate in another location. So if you have run your backups to disk, and then you duplicate that to tape, then that backup set is eligible to be deleted if space requirements are needed. GRT-based backups, that's granular recovery technology, must all be in the same storage location. I can't have GRT-based backups partly on disk and partly on tape. They all have to be together. And the Groom cycle understands that. GRT-based backups of Exchange will not be deleted even if copies exist. So backup to disk for Exchange will always be kept on disk even if it's duplicated on tape. The most recent one will always be kept. All of these rules are automatic. Backup Exec understands that it needs to maintain the drive space so that your future backups can be written there, and it understands these rules. From a configuration standpoint, the only thing that you set is is how long you want that backup to be kept, and you set that in the job. On the screenshot you see in the background here, you see where the full is being kept for 2 weeks and the incremental is being kept for 1 week. That's all you need to do. Backup Exec will automatically delete as needed to recover disk space so that future backups can be written to that same disk space. When you write backups to disk, very often people will also duplicate them to another disk space or to tape or to removable disk. When you duplicate to tape or removable disk, that data is managed using media sets. So let's talk about managing media that is written for data that is written to removable media. Removable media can be tape. It can be disk files that are stored on removable disk or RDX. It is the destination for a backup job or a duplication job, but it is also the source for restore, especially if the original backup to disk has been deleted. Media, meaning tape or removable, always has a header that stores properties about that piece of media. One of the things that's kept in the header is a unique ID for that piece of media, or a GUID, a globally unique identifier. Backup Exec will always track the media based on that GUID. When we look at catalogs, we'll see that GUID again because the catalog files are stored so that we know that they go with a particular piece of media. Media sets are how you define how you want the data to be kept on removable media. The two main properties we're going to talk about right now are the append period and the overwrite protection period. The append period is how long can I continue to add data to the tape provided there's still capacity. The tape's not full. In the first example on the screen, we see that we can append for 5 days. You can overwrite the tape at the end of the overwrite protection period. So Backup Exec will protect all the data on the tape, regardless of when it was written there, for that entire overwrite protection period. So let's take the first example that's on the screen. I write to the tape on Monday, and I can append to it for 5 days. So on Monday, I'm going to protect that data for 30 days. Then we write to the tape again on Tuesday, and I'm in day 2 of my append period, but we're going to protect Tuesday's data for 30 days. Same for Wednesday. On Wednesday, we're in day 3 of the append period, but we're going to now protect Wednesday's data for 30 days. Thursday, we write to the same tape. We're going to protect Thursday's data for 30 days. Friday, we're at the end of our append period. It's the last time I can write data to the tape, even if there's still room left over on Friday, but we're going to keep Friday's backup for 30 days. So Monday's backup that was written 5 days ago will actually be kept for 35 days. You must keep all the data on the tape for the entire overwrite protection period. In the second example, I can append to the tape for 30 days, but I'm going to keep the entire tape for 7 years, which means that I'm probably going to send that tape off-site and not see it again for a very long time. You can change the properties, the append period and the overwrite protection period, as needed. A media set then has these properties for any tapes that belong to that set. And tapes can become members of the set. They can be moved to different sets. When they get moved to different sets, they inherit the properties of the new set. A media set is simply a basket. It's a container that holds removable media. And the properties are assigned to the container. Anything within that container inherits those properties. There are several media sets that exist by default. The first one is cleaning media. Cleaning media is tapes that are used to clean tape drives. Obviously, you can't write backups to those. Foreign media is any media that my database doesn't know anything about. So if I were to create a backup to tape on my Backup Exec server and send it off to you, your Backup Exec server wouldn't know anything about that tape. even though it's still a Backup Exec tape, to your database it's foreign media because your database doesn't know anything about my media set. Some foreign tapes we can read from and restore from, some we cannot. It depends on the software that was used to create the tape. By default, Backup Exec will always ask if it is allowed to overwrite foreign media, and we'll take a look at those settings in a few moments. Keep data for 4 weeks is exactly that. It's a media set that I can write to. It's the first one we've looked at that we can write to, and the data will be kept. The overwrite protection period is for 4 weeks. Keep data indefinitely is data that you do not want to get rid of for any reason. Usually this is data that has been written to a different media set and you moved it out of its original media set into the keep indefinitely because you had a reason to. Perhaps this is a really important backup and we had a server that went down and we just need to keep this as a record of that exact server. Retired media is media that Backup Exec questions the integrity of the physical media. If you have 3 hard read or write errors in a 10-hour period, Backup Exec will automatically move the tape to retired media. A hard error means that Backup Exec was not able to read or write a block on that tape. It's like having a bad block on a hard drive. Tape, though, is magnetic media. It's got a mylar strip with magnetic media on the back of it, and that media flecks off. And if a piece of that magnetic media is gone, then we can't write to that block. So Backup Exec doesn't know what data is missing. So it will automatically move tapes to retired when we have had problems reading or writing to that physical tape. Retired is also the only media set that you can use to delete tapes. So if I had a tape drive eat a tape and I had to get a screwdriver to get it out, I could move it into retired and then right-click on it and delete. When you delete a tape from retired, it does several things. It removes it from the database, but it also removes the catalogs that are associated with that tape. Ordinarily, catalogs are only overwritten at the time that the tape itself is overwritten. So at the time you delete a retired tape, you're saying, I will never again use that tape, and I just want to remove the database entries and remove the catalogs that are associated with that tape. Scratch media is media that Backup Exec considers blank or new. When you get brand new tapes in and you take them out of the cellophane wrapper and out of their little plastic clamshell, you put them in the library and you inventory the library. It's always a best practice to inventory the library anytime you change tapes. If it's a brand new tape, Backup Exec will automatically put that tape in Scratch. Scratch then donates tapes to any media set that needs them for a backup job. So in the bottom of this screen you see media sets for daily duplicate. If I were to need a tape to write to for daily duplicate, Backup Exec would automatically take it out of Scratch and put it into daily duplicate. And then that tape would inherit the properties of the media set daily duplicate, mainly append and overwrite. So that's Scratch's function, is to donate tapes to other media sets. Tapes that you have determined, I don't care what's on this tape anymore, it is eligible to be overwritten as far as I'm concerned, you can drag them to Scratch or move them into the Scratch media set, and Backup Exec will consider them blank or eligible to be overwritten. Even if you have not erased or overwritten the tape in any way, just the act of moving it to Scratch tells Backup Exec that that tape is now eligible to be overwritten. Those are the default media sets. You can create media sets for your own data. Typically, media sets are created based on data type, because usually you will keep different types of data different lengths of time. I usually keep exchange data for a very short period of time, where SQL data that has to do with money transfers tends to be kept for a longer period of time. So I create media sets that determine how long the data is going to be kept using the overwrite protection period, and I create media sets then for the data type so that I can change that time frame for each type of data that I'm duplicating or backing up. So the two main properties of any media set are the append period and the overwrite protection period. The append period is the amount of time that data may be added to the tape since the first time the media was written to. Since the first time, it's a hard clock and it counts down. As soon as you write to that tape for the very first time, the append clock starts counting and it just ticks down. And it says, I can only append or add data to this tape until that counter hits 0. Once that counter hits 0, the overwrite protection period kicks in. So the append period is specified in hours, days, weeks, or years. You see the months is missing. And technically it starts when the media is allocated. I'll talk more about that in a moment. It's easiest to remember that the append period begins the first time that data is written to the tape. The overwrite protection period is how long will the last thing written to the tape be kept. So earlier in my example, we wrote to that tape on Monday, on Tuesday, on Wednesday, on Thursday, on Friday. And every time we added data to the tape, we were within the append clock. It was just counting down. But every time we ended a backup, on Monday's backup, we kept Monday's backup for 30 days. On Tuesday, we kept Tuesday's backup for 30 days. So the overwrite protection period resets itself for the last thing that was written to the tape. Another example of this is if I had a backup that took 48 hours to run. The very first file that was written to that tape would get protected for my whole overwrite protection period. In my example, let's say 30 days. But as the backup runs, and it takes 48 hours to run, at the end of that 48 hours, we're going to keep the last file that we wrote to that tape for 30 days. So the very first file is now going to be kept for 32 days. So the overwrite protection period resets itself every time data is added to that tape. Another viewpoint on this, because this can be a very confusing topic, the append clock is begun when the tapes move from scratch into their media set. So let's take, for example, the screen we had earlier in that daily duplicate. When the daily duplicate job kicks off and says, I need a tape to write to, Backup Exec says there are no tapes in here eligible to be overwritten, so we're going to take one out of scratch and put it into daily duplicate. At that point, as soon as it goes into that media set, the append clock starts ticking and it just counts down. That's an important concept, because if you were to take a brand new set of tapes I just got from my manufacturer, and I take them out of the cellophane wrapper and out of the little clamshell, and I put them in my library and I inventory the library, and I did this on Tuesday, and I have a backup that runs on Friday, but my append period is only 3 days. Let's say only 3 days. So I could, if I wanted to, I could append Monday's backup to Friday's tape. But on Tuesday, I take that tape that I just got inventoried and put in Scratch automatically, and I put it in my weekly backup that runs on Friday. So my append clock now starts ticking. So it's Tuesday, Wednesday, Thursday, Friday, and when Friday hits, that tape is no longer eligible to be appended. So when the Friday backup kicks off Friday night, the overwrite protection period has already kicked in and you won't be able to write to that tape. So it's very important that you understand that tapes, the media set properties are applied as soon as that tape is put into or allocated to a media set. So the best practice is to always let the tapes be in Scratch and be sent to the media set as they're needed so that the append clock will work properly. If that's the case, if they're in Scratch and they get donated to their media sets appropriately, as soon as you write the first thing to that tape, the append clock will start counting and it will just count down. So in the example on our screen, we write a backup job to the tape. And we're still within the append period. At the end of that backup job, the overwrite protection period starts counting and says we've got to keep this data for, in the first example, 30 days. And then, in this case, you see another job kick off to that tape. We're still within the append period, but when that second job ends, we have a new clock for the overwrite protection period. It has reset. And then we send a fourth job to that tape. And we're just barely inside the append period, but as soon as that backup is done, the overwrite protection period kicks off. And now we're going to protect all the data on the tape for that whole overwrite protection period. At this point, the append clock has counted down to 0. And it doesn't matter if there's still capacity on that tape or removable disk. The tape will now be protected for the entire overwrite protection period by default. Once that time has expired, once the overwrite protection period clock has counted down to 0, then the tape will be eligible to be overwritten again. That's the default behavior. You can certainly intervene. You could move it to Scratch. You could erase the tape. But this is the default behavior for how tapes are written to in Backup Exec. Keep in mind that these media set properties with this version of the product apply only to removable media. That was not true in older versions of Backup Exec. So in this version, data lifecycle management just keeps it the time you've said, 4 weeks, that's how long we're going to keep it, and then it goes away unless you write to removable media such as tape or removable disk. And then the properties that you see here apply. So I set these properties when I create my media set. In this case, we're looking at the properties of an existing media set, but you can certainly set them yourself. So what you see here is that the media set has a name. You see the overwrite protection period and the append period. The last property of a media set is one we haven't discussed yet, and that's the vault. So when this tape comes out of the library, where is it supposed to go? Is it supposed to go in the fireproof cabinet? Is it supposed to go in the boss's desk? Maybe it's supposed to go to my courier who does off-site tape storage, such as Iron Mountain or SunGuard or any of the couriers who help you store off-site tapes. The vault property that you see here is a database entry. So this is saying that when you take that tape out of the library, you are supposed to put it in the fireproof cabinet. There's no guarantee, as far as Backup Exec is concerned, that that's really where the tape went. It's just what you were supposed to do. So it helps you keep track of where your tapes are. There are reports that you can run that will tell you which tapes are supposed to go into storage and which tapes are supposed to come back from storage based on the tape is now eligible to be overwritten. And you can auto-generate those reports and email them to your courier if you're using a courier service. So if I email that to my courier, they will have a list of all the tapes I'm supposed to give them today and all the tapes they're supposed to bring me today so that I can re-inventory and overwrite my tapes. So the vaulting has to do with where the tape is supposed to go, but it also allows you to run these reports and communicate effectively with your tape courier if you're using that kind of a service. You can overwrite any tape at any time by either associating it with a Scratch media set. You can just simply erase the tape. Right? You can label the tape, which means to give it a new name, and it will inherit the new properties. And you can change the overwrite protection period if you choose to, so it will expire the tapes in a shorter amount of time. So if you go to the Storage tab you'll see your storage devices. When you look at the tapes, you can then right-click on any tape, and you'll see the top one is to inventory. You can also inventory now. Label is the one that we have the red box around. Label means to write a new header to the tape right this very minute. Effectively, it erases the tape so Backup Exec can't access any of the data on the tape. Technically, it's only overwriting the header on the tape. So at that point, if you wanted to spend the money, you could send the tape off to a data recovery service and they could try to recover the data for you. But Label writes a new header to the tape right now this minute. If it weren't a barcode tape, in this case what you're seeing is tapes that have barcode labels on them. If it were not a barcode tape, you could also rename the tape. Rename means to write a new header to the tape and give it a new name the next time we're due to overwrite it. So the difference between label and rename is label happens right now and it orphans all the data that's on that tape. Rename says at some point in the future, when the tape is due to be overwritten anyway, give it a new name. And so it maintains the data that's on that tape. You can only edit the labels on tapes if they are non-barcoded. If it's a barcode tape, then Backup Exec will use the barcode label name and display that to you as you see in the screenshot here. You can right-click on any tape and go to its property, any removable media, and go to its properties. The media ID is toward the top of that screen. This is the GUID by which that tape is identified. And if the tape gets moved into retired, this is what's commonly people will do, is the tapes will get moved into retired and someone will say, that tape isn't that old and we haven't used it that long. So we're going to erase the tape and move it back into scratch. When you erase the tape, it still maintains its GUID. So even though you put it in scratch, the next time a backup runs and it finds that tape, Backup Exec is going to say, I know that tape's ID, it's a problem tape, and it's going to put it right back in retired. All right, so Backup Exec will always identify that tape by the media ID regardless of what you do. If you change the name or change the barcode label, that's your thing. Backup Exec is always going to identify that tape by that ID. The catalogs about the backups that have been written to this tape are also associated by that media ID, and we'll see that in a few moments. If you keep coming down that screen, you'll see the media set that this tape belongs to. You'll see its location in the library or in the vault if it's been vaulted. The creation date is the first time that the database assigned the GUID to that tape. The allocated date is when it was allocated to that media set. This is also when the append period clock started ticking the first time. The modified date is the last time we wrote to the tape, and that's when your overwrite protection period clock started counting. But below those, you see it's protected until, and you see the date and time stamp, and that means Backup Exec by default will not overwrite that tape until that date and time stamp has passed. And you'll notice that Backup Exec calculates that down to the second. So the very last thing that was written to that tape is when this clock began counting. The append clock is the hard clock that started counting the first time we wrote to the tape, and you'll notice in this screen that we can still append to it. But once that time has passed, then it doesn't matter if there's still capacity on the tape. Backup Exec will not write to that tape. The capacity over on the right has to do with the tape itself. Used capacity is very accurate. Available capacity is going to depend on what kind of backups you're running and how much compression they get. Different types of data compress differently. So used capacity used capacity is very accurate. Available capacity is going to depend on what type of backup that you have. As you come down the right side, you see soft and hard errors. Soft errors mean that we tried to do something to that tape and maybe we missed. We tried to spin to a specific point on the tape and we missed. So we can fast forward or rewind to get to where we need to go. You can recover from a soft error. A hard error means that we tried to read or write a block on the tape and we couldn't. If you see any hard errors at all, it means that you have bad blocks on that tape. And what that means is you may not be able to restore the data that's on that tape. You need to run a test restore, and if possible, just retire the tape. Don't write to it again. Because if you have hard errors, the integrity of the tape is in question at this point. You can set global settings for how Backup Exec uses the tapes. And this is if I go to the configuration settings off the Backup Exec button and go to settings, come down the settings to storage. The first option that you have is to inventory the libraries when the services start. This depends on the type of library you have. Some libraries, when you inventory them, will have to take the tape out of the slot and put it in the drive and read the header, and then put it back and get the next tape and read the header. If this is a large library, that's going to take a long time. Some libraries, when you inventory them, it's just telling it to do a barcode scan, and it will use the barcode reader and just scan the labels on the tapes, the outer labels of the tapes. So that depends on what type of library, how you want to set this. The next section has to do with how well do we protect these tapes, and we're going to go into this in more detail. The default that you see here is partial with a prompt. Partial with a prompt is intended for if you were coming from another backup product and I had tapes that the other backup product had written to. So for a period of time, I do not want Backup Exec to overwrite those tapes until I get a full cycle of backups with Backup Exec. Once I get a full cycle of backups with Backup Exec, then I can allow those tapes to be overwritten and reused because now I could restore the data using Backup Exec. So the default is that we will protect foreign media and ask you if it's okay to overwrite it. And if you were coming from another backup product, initially you would say no, you don't want it overwritten. But after you've gotten a full cycle of tapes with Backup Exec, then you could begin to say yes and reuse your tapes. The bottom part of this is very, very important, and this has to do with where do we go to look for tapes when we need it first. The default is to overwrite scratch media first. It's recommended that you change that default to overwrite recyclable first. So let's take a look at how this impacts and where Backup Exec is going to go to look for tapes. So if you change that default so that you overwrite recyclable first, when the backup job kicks off, Backup Exec will say, I'm trying to write to my media set and I don't have any tapes to write to. So I'm going to go look in my current media set and see if anything is eligible to be overwritten. If there's nothing in there that's eligible to be overwritten, the overwrite protection period has not expired for anything, then Backup Exec will go to scratch and find a tape. But you'll notice that the first thing it wants to do is overwrite any tapes that are available to be overwritten before it goes and gets a brand new tape. And that's the impact of this radio button. If it goes to scratch and it can't find any tape to write to, it will go to any media set and look for tape that's eligible to be overwritten. If it can't find anything there, it will go to imported. If you're set at partial with a prompt, and that's the default, it will go to imported media and say, am I allowed to overwrite this tape? And you have to say yes or no. So full protection means that we're just going to take your settings, your overwrite protection level settings, and enforce them according to the rules that Backup Exec uses. We won't ask you, we're just going to enforce them. Partial with a prompt means that when it comes to foreign media, we may ask you, is it okay if we overwrite? None means that we can overwrite anything at any time, regardless of what the overwrite protection period is. None is risky in a production environment because you could overwrite any tape at any time. It will try to overwrite the one that is closest to being expired, but that's not always the case. So none is appropriate for test environments where you don't really care about the data, but you wouldn't want to use it in a production environment. The difference between these two radio buttons, overwrite scratch and overwrite recyclable, is really apparent if you leave it at the default. If I leave it at the default, which is to overwrite scratch, when the backup job kicks off, it's going to go and say, is there a brand new tape available before it does anything else? The result is that you'll never have blank tapes left in your library because it will use those up first. If it can't find a blank tape, only then will it go into the current media set and say, is anything here eligible to be overwritten? And if the answer is still no, we'll go to any media set and see if it can find a tape. So leaving that at the default means that it will always use blank tapes even if a tape is eligible to be overwritten, which is why we recommend that you change that default. If the tape has a barcode label, if you've put a barcode label on the tape and the library has a barcode reader, then that barcode label becomes the tape name, and that's what's displayed to you in Backup Exec. The first rule I'm going to give you here is if you throw away the tape, throw away the label. Don't reuse the labels, because if you reuse the labels, what will happen is I will have now two tapes displayed to me in Backup Exec that have the same name, but they're different tapes, and if you look at the properties, they have different GUIDs. So if you throw away a tape, throw away the label. So the barcode label takes precedence. You can remove the label from the cartridge, and at that point you could rename it if you chose to, but Backup Exec knows that it once had a barcode label. Barcode rules tell Backup Exec which tapes can be used by which drives. And this is particularly important if I have a library that has multi-generational tape drives in it. So if my tape library has an LTO3 drive and an LTO4 drive, then these barcode labels tell Backup Exec which drive can read which tape. To create a media set, there are several different ways you can do this. I can just right-click when I'm looking at media in any blank space and say Create Media Set. When you tell it to create media set, you're going to come into the screen with the properties. I have to give my media set a name. I need to set the overwrite protection period and the append period. If your default is set to none, remember full, partial with the prompt and none, then we can overwrite that tape regardless of what your overwrite protection period is. And at the bottom of this screenshot, you see a message that comes up on the screen to tell you that you have your protection period set to none, and that's not a best practice. There is another property of a media set, and that's the vault that also shows up on this screen. It's just that it's further down than the screenshot allowed us to see. I can associate any removable media set with any removable media, tape or removable disk, with any media set. You can do it by a drag and drop. You can right click on it and say associate with media set. If you associate with media set, then it gives you a drop down menu and you can choose the media set to which you want this tape to be associated. If you associate it with retired, you can delete it, which means to remove it from the database and remove the catalogs. If you associate it with scratch, you're saying, I don't care what's on this tape, it's eligible to be overwritten. Catalogs are how Backup Exec keeps track of what you backed up, where it came from, and where it went. When you do restores, Backup Exec is not reading the media, whether it's disk storage or tape. What we're reading is the catalogs. So let's take a look at the catalogs themselves. Catalogs are just files. They're flat files that are stored on the Backup Exec server. They're created at the time of the backup, and they're used to do restores. Every catalog is going to consist of two files. The format of the file name is the media ID, that's that GUID, underscore the backup set number. We'll talk more about backup sets in the next lesson. .fh or file header and .xml. FH is the full path to where the file came from. So it's how we can restore back to the same location from which we backed up, because the FH catalog keeps track of the entire path and file name of where the file came from. XML is where did that file go. When we backed it up and we wrote it to that LTO tape, in all those feet of LTO tape, where is my little 10 meg doc file? And so XML keeps track of where did we put the tape, where did we put the file when we backed it up. By default, catalogs are written to the server's hard drive in the C:\program files semantic backup exec catalogs directory. So they're written to the C drive by default. You can move those, and it is a good idea to move them. But they are also written to the media itself. So the catalog will exist on the Backup Exec server and on the tape. When the tape is overwritten, then that catalog is removed and a new catalog is created for the new backup that was written to that tape. So if you're keeping tapes forever and ever, amen, if I do backups and I keep tapes for very long periods of time, the catalogs directory will get larger and larger and larger because those catalogs are being kept as long as the data on the tape is being kept. The database, the Backup Exec database, has an index to those catalogs. So I always have to do things in pairs as far as dealing with the catalogs and the database. They go together. Even though the catalogs are flat files, the database has an index to those catalogs. If you choose to move the catalogs, Backup Exec is very friendly here. You can move them at any time. Here you see the default path for where they are kept. It is a best practice not to keep data on the C drive. Data should go anywhere but C. So if you choose to move the catalogs, you can do that. What you should do is copy them, not cut, but copy from their old location to the new location. Come into this screen. This is off of your configuration settings screen. Change the path. Backup Exec will tell you that the services need to be restarted. Anytime you do anything with the catalogs, it needs to restart the services. And then attempt to do a restore. You don't have to complete the restore. You just need to be sure that Backup Exec can read the files in the new location. Once you do that, then you can go back and delete the files from their old location. Other things that are important on this screen. The top checkbox to request all media for catalog operations is on by default. So what that means is I had a backup that spanned 3 tapes. And I created that backup and then I sent those tapes to you. Your database doesn't know anything about those tapes, so they're foreign, and it doesn't know what's on them, so you'll have to catalog them. If you put any tape in your library and say catalog this tape, Backup Exec by default is going to ask where are the other 2 that go with it, because it spanned 3 tapes. So we'll always ask for all the tapes that go together. The next one here is to use storage-based catalogs. That means that we're going to write them to the hard drive. The truncate catalogs can be particularly important if you're keeping data for a very long period of time. If I'm keeping data for very long periods of time, the catalogs directory gets larger and larger and larger, And when I go to do a restore, the restore screens are very slow to populate because Backup Exec has to read all those catalogs. So one option you have is to tick the checkbox for truncate and set a time here that says truncate any catalogs that are more than, let's say, 1 year old. What that does is it removes the data from the catalog file. So your .fh and .xml files will all of a sudden only be 8K in size. They'll be very small. The file will still exist, but all it is a header. If I choose to do a restore of a tape that is more than that time frame old, so in my example I said 1 year, if I have to restore data from a tape that is more than 1 year old, I'm going to have to catalog it again and rebuild that file out to its full size. So truncate catalogs has to do with keeping the size of the file on the server's hard drive small so that my restores run faster. But I should only truncate things that I probably will not restore very often because I don't want to have to run catalogs very often. So usually you're going to truncate catalogs for data that you've kept a very long period of time, 1 or 2 or 3 years. But it does make restores run much faster in that instance. To catalog a tape, if this were a tape that someone sent you or you had truncated, you could just right-click on the tape and say catalog. When you catalog the tape, it runs as any other job. It will show you the device that's running it and that the job is running. If the tape is password protected, it will prompt you for a password to put in there, and that's usually only older tapes. So you'll see the job run, and it will show you, hopefully it was successful. We like those that are successful. And once it has run, you can restore any data that's on this tape. So you have to catalog the tape and create that .fh file and that .xml file before you can do any restores. So we have talked about how to organize my media using data lifecycle managements and how Backup Exec is going to groom disk-based storage automatically. We have talked about how to organize media into media sets. Usually this is done by data type so that I can keep my overwrite protection period for the different types of data to different lengths of time. And we talked about why catalogs are important. That's the only way I can do restores, and where they're kept and how they're kept.